Hey everybody, Joe here. Gonna check out a puzzle today by Chip Sounder called A Dot of Killer Heat. The rules are place the digits 1 to 8 in every row, column, and 2 by 4 box without repetition. Digits along a thermometer increase from the bulb end. Digits cannot repeat in a cage. If a number is shown, that is the sum of the cage. Digits separated by a black dot have a ratio of 1 to 2. Digits separated by a white dot are consecutive. And that is all of the rules. 98765. So this has to be 1 to 5, 5 being the maximum. This one cannot have a 5, but it would be the same otherwise. 6, 7, 8, 9, so that could be a 3. This cannot be a... That cannot be a 4 though, because this would have to be a 2 or an 8. Neither one of those would allow the thermometer rule to work. So this will be a 2, a 4, or a 6. And then this will be 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, 5, 6, 7, 8, 9. Got a lot of pencil marks, but so where are there any boxes that do not have ends? So it's quite a lot there actually. So a 9, for instance, a 9 can only go in this little L shape and this little L shape. 9's only going to go in that little L shape as well. But it could go in one of those, which it will go in one of those, because it can go nowhere else on the thermometer. And it could share with 8, as in this could be an 8-9 pair. Well, 9's gonna be on one of these, huh? And they're gonna be like crisscross from each other, or X-wing, or however you want to say it. These will be the same, I suppose, with these, like that. Because there has to be a 9 on this row. So that in turn means that a 9 will not go here or here, because they're going to be sitting like this or like this. Now this cannot be an 8, this cannot be a 7, that cannot be a 6, therefore this cannot be a 3. Same thing here. That cannot be an 8 now, or a 7, or a 6, or a 5. This cannot be a 9, but I think this still could be. No, it cannot be. A 9 cannot go there. A 9 either goes there or there. A 9 can go there, there. It won't go there though. So something like that. So 1, 2, 3, 4, 5, 6, 7, 8. So this cage is missing one digit. Is it a 9? A 9 cannot go here. A 9 can go there or in one of those. And which one is it? What about here? This box either has to be this digit or one of those. What about these two? This one maybe? These have to be consecutive. Oh, this will have to have a 2 on it, won't it? So no other 2 can be in that column. A 2 cannot be here. Now a 2 cannot be there. A 2 is in one of those. A 1 cannot be there. It could be here though, if that was a 2. A 2 could be here though, easily. Cannot be there though. So it cannot be there. So 2 cannot be here. A 2 cannot be there. Cannot be there. It's either here or here, isn't it? For this column, it's one of those. So for this column, it can't be either one of the... Oh wait. But it could be that one though. Otherwise, it's right there, huh? But it could be in this column as well. So I don't think that's quite there. It's close though. It is very restricted. So it can't be in any of those. Maybe think on 1. A 1 cannot be... A 1 is going to be in one of these. Ah, those have to be a 1, 2, don't they? Because one of them has to be... No, I guess the 2 could be on the same side as the 1. But one of them is a 1. And they'll be in opposite corners, obviously. 5. 5 cannot go there. It could be on the thermometer though, it could go there. This digit has to be on the thermometer. But it could be there and be 5 or 6. So this is a 1 or a 2. It has to go in one of those spots. A lot of these are close, but they are not quite. It's 2, 4. If that was a 4, it could go on the thermometer. It could go there as well. It could go in that whole row. It's a 2, it'd have to go in one of those. This number here could also be any of those. What was this other one? This one maybe is either here or here. What about this one? Does this one have to go in the box? What digit is not in this cage? Don't think I know that yet. I just know that it's not a 2. How did I get that? Oh, right, because this can be a 2, another one of those could. So the 2 cannot go there, but it could go there. It cannot go here, because this could not be a 3 or a 4. Or, I mean, a 3 or a 1. But it could go there. If it did go here, it would be there, there. This cell here will not be on the thermometer. That digit. So it's either there or there. These are how many digits? 7. All of them are 7 digits long. These two numbers will not be on the thermometer either. Must they go there? If they're a little bit high, they could be there. Digit will not be on this thermometer. This digit will not be on that thermometer either. But it could be there. This is tricky. This number can't be in there. This number will need to be in, or no, it doesn't even necessarily have to be in this cage. 3, 4, 5, 6, 7, 8. If it was 9 digits, at least I would know it would have one of each number. But then maybe it would be too simple. I doubt it. Okay. What about 8? Oh, these don't have 9s. What am I doing? These 9s are 8s. And then these are not 8. Okay. That should simplify things a bit. And now, this cannot be 7, cannot be 6. Could still be 4. Alright. So 8s are taken along there, and they're taken along here. So where does 8 go in here? And it does have one of every number, because there are 8. So 8 will need to go in this cage now. And 8 cannot be on the thermometer. It could go there though. Seven. So this number will be somewhere here. Now, if it's a 2, it can't go there. It could go... It can't go there either. So if it is a 2, it would have to go there. Then it would have to go there. Then it would have to go in one of those. But it could just as easily be there, like that. Doing that kind of thing. These are a max of 5. That might get crazy. So the corners are going to have a 1, but then what other number? This number will need to be down here. Either both of these go here, or one of them can go there. Eight cannot go here, can it? 8 goes somewhere down here. This is not 8-2. It can be 6-4 or 7-3. And that is all. If it is 6, 4, that is 7. That is 5. If it is, oh, hold on, what did I just say? If it's 6, 4, that's 5, that's 7, and one of these is 8. That's 4 through 8. Then we have 1, 2, and 3 left. And this cannot be 1, 2, or 3. Neither could that one. So this is not 6, 4. So this is 3, 7. Now this is not 7. Now this is not 6. Now this is not 5. Now this is not 4. So this is 2. And this is 1. Now 1 has to be there also, and now it cannot be, it's either here or here. 1, 2 is making a pair. Three, 7. I don't have a 1 here yet. 1 is there or there. 2 cannot go there. 2 is here. 1 is here or here. I stated earlier, just didn't mark it. 4, 5. Or rather, this number must go here or here. You could go there as well, though. Let me think on this one, maybe. Three, 7 means 3 does not go here or here. Well, that's obvious. 1. 5, 6, and then whatever's not these two. 5 and 6 have to go somewhere there. Which is here. Okay. This digit. And 8 goes down here somewhere. If this is 5, that is 5. The corner can still be 5. This cannot be 7. And something to think about now. Even 6, maybe. Seven and 8 cannot go on those highlighted cells at the moment. But there are still 4 open. 1 and 2 could be in 1. 5 and 6, of course. I'm just not sure. Red is in one of these. Let's go ahead and just do it. Maybe do green here. Let's see if I can get some sort of understanding there. This could be green. This will have to have red or green on it. It will not necessarily have both. But I think it could. What if it did? If it had both, red and green. This would be red, that would be green. Red, red. Red could be down there. Red could be there. If this was green, that would be green. Green could be down here and there. So I mean, that would work. And green could be there. Green would be there. Green could be there. That does seem to work out just fine. Well, this is one of the two. It is that one. And that one can definitely not be there. So it will be one of those. That could be two though. Well, if this was two, that would be one. if this was 1, that would be 1. One. 1 and 2. No, just 1. 1 has to go there. But 1 can go like that. If this was 1, then that would be 1. That would be 1. That would be 1. That. Then it would have to be there. It would have to be there. It would have to be there. That doesn't look too bad. This would be green. That would be green. 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 And green would be one of those. Green would have to be that one. So it would be that one, that one, that one, that one. Then it would have to go. It would have to go there because that would be red. Now I've kind of lost track. This is green, that is green. I think this one was green. No, I don't know. Having 1 highlighted there too was kind of confusing. If this is 3, what about if that is 5? 5 would be there. That's not much to help, I don't think. Okay. Can I do any more with something in here. I'm thinking probably not. This one. Well, whatever these are, they're there and there. In some arrangement. What arrangement is that? No idea. This one cannot be there. It cannot be there. This one is here or here. One, two, three, four. 1, 2, 3, 4, 5. I guess this could go over here though, and then up there. This was 4. Could go there. Nah. But this cell does go here. Not much to go on. Oh, how am I stuck here? Red or green has to go here. Because only one could go there. So do both of them go here? It means that red definitely does. No, because red could go there. And then down there. Ah, that is so weird. Green could be... Well, or else red goes here. If red does go here, green has to be here, and then it would have to be in the corner. If red goes here, green could be right there. No, it couldn't. Red and green cannot both go there. Because if they did, then they would both need to be down here in this 2x2. And that's the only one that both of them would be able to go to. So red and green cannot go here. Meaning that these are a red-green combo. They are not 3, 4, 5. This is red or green. And then this one will be red or green. Is that gonna be like the other way as well? That I'm not sure of yet. Oh, it will, won't it? Because now this one will have to be up here. And if this is green, if it's red, it's gonna be 1 and it obviously can't go there. So it'd have to go there. But if it's green, then this would be red. And then it couldn't go there because that would have to be red again. So this will be the other red-green. So 1s and 2s are going to be in corners opposite each other. And then so this one will be down there somewhere. Well, I don't know about this one yet, do I? Or do I? Am I safe to say that is also a red or green? This one is this one. But can this one be this one? I think it could, honestly. Oh wait, what did I just ask? If this one can be this one? If it was 2. I think so. That would be 1, and then that could be a higher number, maybe. If I'm not thinking too crazy. But this and this are not 2. Meaning this is not 3. Meaning this is not 4. This was 2, and that was 2. Say this was 2. That would not work. Well, what if 2 did not go on this line, though? 2. Two does have to go here somewhere. 2 cannot be over here. So this cannot be 2. But this could be 2. And this could be 1. But that's the only spot that it could be. So this is going to be the other red or green. And now whatever this is, well, green is in the middle too here. The green will have to be in the middle too here. Green cannot be down here. So this has to be green. And then this has to be green. Because red is the only one that can be kind of out of place here, if you will, with that one. So green is obviously, well, it's only in one of those 2. But here, it can be in one of those. Those are the central 2 vertical columns. So since it cannot be here, it has to be in this column somewhere, and that's the only spot it can go. So that one is green. And now, same thing with red. This is the only spot in the column that can go. So that one is not red. This one is a 2. Ones are red, 2s are green. Check out all the 2s for me. So we're like that. And now red has to be there. Twos are almost sorted. I think 2 could still go there though. So we're not quite sure on that one yet. Now what do we have? This will be 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8. This is not 7, however. What number do I think of next? These will all be kind of the same deal going around. These 2 are not 7 though. This cannot be 6. So 7 is probably going to be the next kind of limited one. Maybe not. 5, 6, 8, 4, 5, 6, 8. That's not any helpful combo. 4 is only one of those 2 though. I think you could go a few places down here, however. What about maybe 8 next? We've already got the 8s on these X-wings here. So in this column, it's there or there. In this box, actually, it's in one of those. It is in one of those. In this top one, it's in one of those. It's quite a lot, eh? It's like that, I think. There's not much though. Not much help, I don't think. Maybe with 7 also? Five, 4, 7, 6, 5, 4. If this was 7, this would have to be 7, 8. I said if that, yeah, if that was 7. Is that a problem? This is 8. That is 8. And then that is 8. And then it's broke. Because 8 cannot be here. So this cannot be 8. So 8 is in one of these two, which does put 8 down here. 8 has to be on the end of the thermometer because there's not a higher number to follow it. That is not 8 now. 8 cannot be in this box, so 8 has to go here. That is not 7, that is not 6. This is now, and 8, it had to kind of X-wing with the bottom one at the top. And now 8 can only go here. It can't go in the cage because we know it goes there. So 8 is here. Now 8 is in, 8 here had to X-wing as well with this one. So I think we have all our 8s now. This can now not be 6, cannot be 5. Okay. 7 needs to go in this box. This cannot be 4, or else a 2 would have to be there again. So we do have a 5-6 combo in the column, making that a 4. 3, 2, and this has to follow it down to 3, 2, 1. This will now be 2, that will now be 2. This will be green, that'll be green. This this cannot be 5. Okay. A 1 is in the box. The other 3 or 4, this 3, 4 has to be here. I don't have a 3, 4 yet, so it's gonna be there or there. Unfortunate, because it could be there or there as well, or there even. So this 4 here could be in the box cage. Okay. 5, 6. Oh no. Let's see. One of these. 3, 4, 4, 5, 5, 6. That's okay, I guess. Six. Just had 5. If it was 5, it would be 4, 3. That would be 6. That would be 7. That would be 5, 4, 3. That would be alright. This 3, 4 is going down here. In one of those. Which means that a 4 is along here. Because no matter what it is, if it's 3, it still has to be the 4 that is consecutive with it. And of course, if it's a 4, then it's already a 4. So there's not a 4 on this side. Down here. But this could be 3, 4, whatever, and that could be 3. It's still why I don't know it, in other words. Now this is the only thing that is a 7 in this column. It might have already been, but I'm just now seeing it. Now 7 goes down here. Maybe there, maybe not. 7 could be in this box or something. But it might end up forcing it. 7 cannot be on this row here though, so it must be on this one. And it must be there. This is now not 7. So 7 will be one of those two. And it will also be in one of those. I do think it could go there though. Seven could be here, here, and here. If this was 7, seven would have to be there and there. And there. It would then have to be there. Yeah, that looks to be okay. What can this be? 3, 4, 4, 5, 6. 8. 8 has to go here. And it can only go there. Now 8 has to go there. Now this has to be 7. And now this down here has to be 7. And now this here has to be 7. And now 7 will be in this cage. So not there. And now it will go here. And I think that will do 7 other than the tin box. Okay, now we have 4, 5, or 6 right here. 2, 3, 4. This is 5, 6. Meaning this is a 3. This is a 4. So a 4 is on this. It is the lowest digit. So since it's on a thermometer, it will stay on the lower side. Now this is 5, 6. This is 4. I can still be either. This is 3 though. 7, 3. And that's just gonna get a bunch now. So I'm gonna do the whole puzzle now. Maybe I did not do this quite efficiently, as oh my gosh, that almost cleared all my pencil marks up, except for one. This is a 5, 6. We have a 3, it's blue right here. 4, 6, there and there. This will be a 4. This will be a 5. This will be a 6. And that does it. Alright. Well, after that break-in there, I thought it did have a tricky break-in. Maybe I wasn't seeing what I was supposed to see. But very nice puzzle by Chip Sounder, A Dot of Killer Heat. Check it out for yourself in the link below. Like and subscribe if you enjoyed, and thank you so much for watching. Bye bye.